So this is going back to grade 10. Remember, we can use Pythagoras, a squared plus b squared equals c squared, to find missing sides in right triangles. We can also use trigonometry to find missing sides and missing angles in right triangles. And there's 3 trig ratios, and they each represent the proportion of one side of the right triangle over another. How do we know? Well, it depends on what angle we're talking about, the acute angle. So for example, if the acute angle is down here, this side would be called the opposite. The longest side, or opposite the right triangle, would be the hypotenuse. And then sort of by default, that's going to be adjacent. Right? And how do we remember these ones? SOHCAHTOA. So really, all you're doing with trig here is you're setting up a very simple trig equation and solve. So like example 7. We're asked to find the length of side A. And we're given this acute angle down here, and we're given this length here. So if this is the angle we're given, what's the name of this side? Opposite, adjacent, or hypotenuse? Opposite 35. And what's the name of this side? So we're dealing with opposite and hypotenuse, which means sine. So that tells us what trig ratio we're going to use. So we're going to use the sine of the angle, 35 degrees, will equal the opposite side, which is called A, over the hypotenuse, which is called, or which is 12. So now you just solve this equation. Solve for A. How do I get A by itself? Times both sides by 12. So A is going to be 12 times sine of 35 degrees. And we use our calculator to figure that out. And let's just go to one decimal place. Remember, you may still be in radians. I know it's weird. You guys just finished today learning about like quadratic trigonometric equations in radians.
What?
6.1.
I didn't learn that, and hearing that just made my brain hurt.
Well, it's not till next year. You're doing some trig equations this year, and it's meters. Okay. For number 8. We are asked to find the length of the hypotenuse. Which one is the hypotenuse? What's that? There's 2 blank ones. Okay, and I'll call it X. Yeah. So we're given the 58-degree angle. Well, X is what side? Opposite, adjacent, or hypotenuse? Hypotenuse. 8 is which side? Remember, wouldn't this one be the opposite 58? So this by default must be adjacent. So I've got adjacent over hypotenuse, close. So what does my equation look like? Which is, in this case, 58 degrees equals. Good. Now I got to do a couple of steps here, actually. First of all, how do I get rid of the fraction? Times both sides by X. going to give me x times the cos 58 equals 8. So I got rid of the fraction, but I still don't have x by itself. Divide both sides by cos 58. And now you're ready to use your property. And again, so that's the place. So 8 divided by the cos of 58, 15.1, and it's in inverse. Good. So notice that we use trig. In a trig equation, the missing side could be on top, the missing side could be on the bottom, or the third case, the angle is missing. So you're asked to find the measure of angle A, this one here. Now you could give it a variable name. You call it little x if you want, or you can just call it capital A. So let's set up our trig equation. If this is the angle, what's the name of this side? Opposite, this side, hypotenuse, sine. And it's the sine of the angle, but remember, sine, the angle's unknown. Equals the opposite side 8 over the adjacent side 12. Now, how do I get A by itself? How do I get rid of just sine? Inverse. So A is going to be the sine inverse of 8 over 12. Remember, when you find a missing angle using trig, you always use inverse. One decimal place again. 30 looks like 30.
Yeah.
Oh, what did I put 12? 16. It's still 30 degrees, you're right. I just wrote 12 instead of 16 for some reason. Okay. So that's a review of trig. Just a couple of other little things. Okay. We can actually use triangles to come up with a formula to find the sum of the angles, interior angles, in any polygon. Because you can take any polygon and split it into triangles. For example, how could I draw a segment inside to split this four-sided shape up into triangles? See the angle. Either one. Both are right. What's the sum of the angles here? In this triangle? What's the sum of the angles in any triangle? 180 degrees. What's the sum here of this triangle? The same. So what would be the sum of all of them in the four-sided shape? 360. Okay? So the sum equals 180 plus 180 equals 360 degrees. Oh, sorry, I shouldn't have had it down here. We can do the same thing, like I said, with any polygon, regular or irregular. So here, how would I split this up into triangles? Tell me where to draw segments so that I end up with all triangles. B to F, C to E, B to E. Good. How many triangles did I make?
4.
4. and each one is 180. So how would you find the sum of all the angles in this six-sided shape? 4 times 180. 720. There's a pattern. In a four-sided polygon, I could make 2 triangles, right? In a six-sided, I could make 4. How many do you think I could make in a 7-sided, following the pattern? In a 4-sided, I could make 2. In a 6-sided, I could make 4. In a 7-sided, I could make, what's happening every time? Or it's the difference between the sides and the number of triangles is 2, right? So in a 7-sided, how many could I make? 7 minus 2. 5 triangles. Right? Like, look, here's the 5-sided shape. I could go like this. How many triangles did I make? So in a 5-sided one, 3 triangles. Up here, in a 4-sided one, I could make 2 triangles. In a 6-sided one, I could make 4 triangles. So it's always, the number of triangles I can make is always 2 less than the number of sides. Right? If it's 5 sides, the number of triangles is 2 less, 3. If it's 6 sides, the number of triangles is 2 less, 4. If it's 7 sides, I can make 5 triangles. If it's 100 sides, I could make 98 triangles. So we can make a formula out of this. And the formula is, to find the sum of the angles, you do n minus 2 times 180. That's it. Where n is the number of sides in the polygon. This is the formula. You won't have to worry about putting it on your reference sheet because you will get it on the formula sheet. You will get this on your formula sheet. So you don't have to waste space putting it on your reference sheet. I'm sure you'll watch your space for other things. Okay. So just with this one, how would you do 10-sided? 10 minus 2 times 180. You don't have to worry about drawing you don't have to worry about drawing a 10-sided polygon and drawing all the triangles, even though it could potentially be fun. So 8 times 180, 1,440. Finally, with triangles, take polygons. Okay. We can, in regular polygons, that's important. They have to be regular to do this. In any regular polygon, you can draw triangles around the center of the polygon. So for example, if I had a regular 4-sided shape, which is a square, I could draw triangles like this for them. Okay. In a 5-sided regular polygon, 5 triangles. In a 6-sided regular polygon, which would look No, sorry. We can have draw 6. Yeah. Like that. Sort of. No. No. Yeah. No, that doesn't seem right. Slide is insert a picture. No, I don't want to insert a picture. I gotta get this right. I'm drawing up. I have a straight tolerance. Yeah, you guys will probably be able to Google it up and figure out before me. No, it won't show me one. What am I doing wrong? Okay, I'll have to Google it up. Why do I feel like I'm confusing it with an octagon? There it is. That's how you do it. That's weird. You need flat sides here. That's a regular hex. I didn't quite do it the same as that. Well, I did sort of do it the same. I just kind of took it. But again, you can make triangles out from the center. 6 of them. Okay? So these 6 triangles, all the angles in here, called central angles, because they come out from the center. What do all 6 of these add up to? Complete circle. How many, what many degrees in a complete circle? Don't overthink. Complete circle. If you spin your car halfway around, you do a 180. If you spin your car all the way around, you do a 360. So the sum of all of these is 360. Because remember, a complete revolution is 360 degrees. So how do you find the measure of each one? Take 360, divide how many triangles there are. So the sum of the central angles are always going to be 360. Therefore, to find the measure of each central angle, it's going to be 360 divided by however many sides there are. N is equal to the number of sides. Again, this is one that you will get on your formula sheet. You won't have to worry about putting it on your reference sheet. I mean, you still can. Wow. So really, it's just a matter of recognizing the question. So the measure of each central angle, using your formula, 360 divided by 12. Will tell you the measure of each central angle, which works out to 30 degrees. Okay.